So let's get started. Thank you so much for attending this webinar. Today's webinar is about sustainable irrigation. It's about sustainable irrigation, understanding industry trends, and Friend of the Earth Sustainable Irrigation Certification. Next webinar will be on the 31st of March at 4 p.m. Central Europe time. And it will be a Friend of the Earth webinar about Friend of the Earth certification and update. Just a few slides to present our organization in the context of this webinar. Our story dates back in the early 90s with my involvement in the Dolphin Safe Tuna program. I soon realized that certifications could be a very important tool to achieve tangible conservation results. So in 2008, we launched Friend of the Sea, initially focused on certification of seafood from sustainable fisheries and aquaculture. 10 years later, we launched Friend of the Earth, initially certifying products from sustainable agriculture and farming, and now into sustainable fashion, sports, and many others. In 2022, we created the World Sustainability Foundation, and in 2023, we opened our first Sustainable Friends concept store in the center of Milan. Friend of the Sea and Friend of the Earth therefore represent also conservation projects managed by our World Sustainability Foundation in over 40 countries. These are the Friend of the Sea and Friend of the Earth conservation programs on a global map. Some of the projects are developed and managed by the WSO and the Foundation, while others have been selected and certified based on their tangible conservation achievements. Currently, over 5,000 products from more than 1,500 companies in 90 countries carry the Friend of the Sea and Friend of the Earth certification logos. Friend of the Earth certification in particular, and as explained, started some 5 years ago as a certification of products on sustainable agriculture and farming. The Friend of the Earth standards requirements cover all potential environmental and social impacts of agriculture production to meet the expectations of consumers requesting for a comprehensive sustainability certification. These are some of the Friend of the Earth certified products carrying the Friend of the Earth logo. Over the years, the scope of the Friend of the Earth certification has been expanded to award with the Friend of the Earth logo other products and services which respect the environment. A generic Friend of the Earth standard has also been designed for those new products which lead their sector in reducing the impact on the environment. Companies can also leverage on other certification logos we developed to confirm compliance with subsets of requirements of the two major Friend of the Sea and Friend of the Earth standards, such as the famous Dolphin Safe, the Turtle Safe for seafood products, and Sustainable Irrigation, the theme of today's webinar, for Friend of the Earth Sustainable Agricultural Standard. I will go more in detail on this at the end of my presentation. Let's now dive into the subject of today's webinar. Irrigation, the deliberate application of water to land or soil to support the crop growth, has been a cornerstone of agricultural development for millennia. By supplementing unpredictable rainfall, irrigation enabled early civilizations to transform arid and semi-arid regions into productive farmlands, ensuring food security and fostering societal growth. For centuries, the two major sources of water were rain, surface water, and groundwater. Water has been extracted from rivers, collected in reservoirs, and with wells and pumps from under the ground. Nowadays, new sources of water are being used, which can solve the water crisis. Three sources in particular are very promising. Deep sea water, DSW, which is high-quality groundwater, typically sourced from deeper aquifers that are located below shallow aquifers. These are massive and found almost everywhere around the earth, including under the desert and the oceans. Another relatively new system to obtain water is desalination, the process of removing salts and other minerals from water, making it suitable for human consumption, irrigation, or industrial uses. and wastewater treatment, which technically does not generate new water for consumption, but cleans water that has been polluted to be again available for consumption. Water withdrawal, defined as water diverted or withdrawn from a surface water or groundwater source, has grown almost tenfold in the past century, mainly because of its use in agriculture, the blue area in this graph. This represents approximately 70% of total water usage, agriculture. Some of this water is used to grow crops for human consumption, and some 70% of this 70% is used to grow crops to feed animals in farms, farmed animals. A study estimates that 40% of the world's food in agriculture is produced using irrigation. While we all know that water goes in a cycle and eventually gets back to land in the form of rain, two major problems have to be considered when using water. Water can be polluted after use, and thus it might not be used anymore unless treated and cleaned. This map displays overall water quality risk for the three major water quality indicators: nitrogen, electrical conductivity as a measure of salinity, and biological oxygen demand. Another issue when using water is water stress, or the ratio percentage of water withdrawal versus total available water. In these past 30 years, the situation has worsened for USA, for China, as you can see in this map, for South Africa, and most of North African, Middle East countries, and India. These have increased their water stress. So much water is used compared to what is available, that there is a stress, a risk of not having enough water during drought, etc. And this is why optimizing and making sustainable irrigation can really make a change in consideration of its relevance on the overall global use of water, as we have seen. But let's take a step back and understand the importance of water for plants. We all know how water is essential for their lives, in particular because of photosynthesis. As you can see, during photosynthesis, plants trap light energy with their leaves. Plants use the energy of the sun to change water and carbon dioxide into a sugar called glucose. Glucose is used by plants for energy and to make other substances like cellulose and starch. Cellulose is used in building cell walls. So water is fundamental for photosynthesis. But water is not used by plants only for photosynthesis. Plants are made from 50 to 90% of water. So water is important, for example, for flow of nutrients and make them available to all the parts of the plant. Water is also solvent for chemical reactions between the nutrients absorbed. It allows growth of microbes which are essential to plants, and so on. So now that we understand the importance of water and why crops need a certain amount of water, sometimes more than what rainfall can provide, let's look now at how irrigation, which compensates for this demand, and its technology has evolved over time. Where do we stand now and what we could expect to happen in the future? The earliest known irrigation systems date back to ancient Mesopotamia, around 6000 before Christ. The Sumerians, living in the Fertile Crescent between the Tigris and Euphrates River, developed simple yet effective methods to channel water to their fields. Using a network of canals, dikes, and gates, they could control the flow of water, ensuring their crops received adequate hydration during dry periods. They made levees between the two rivers surrounding the area, so that water would flow from the higher river, to the lower one. It worked for the farmers upstream, but the people downstream often had to deal with dirty water filled with silt or sometimes during dry seasons, no water at all. Similarly, in ancient Egypt, the annual flooding of the Nile was harnessed through basin irrigation, as you can see from these images. Farmers built earthen embankments to capture flood waters, which then slowly seeped into the soil, nourishing crops. Flood water would be directed into a basin where it would sit for a month or so until the soil was saturated. Then the remaining water would be drained off to a basin down gradient or to a nearby canal, and the farmers of the drained plot would plant their crops. This technique was instrumental in supporting the agricultural productivity that underpinned the rise of the Egyptian civilization. Shaduf was a hand-operated device for lifting water used to help move water from the canal to the fields. A Nilometer was used to predict flood levels of Nile River. This instrument was a method of marking the height of the Nile over the years. Nilometers were spaced along the Nile River. They acted as an early warning system. Around 3000 before Christ, irrigation techniques began to flourish in ancient China and India. The Chinese developed intricate canal systems and used water wheels, known as norias, to lift water from rivers to higher grounds. These innovations enabled them to cultivate rice paddies, which required consistent and controlled water supply. Another example is the Dujiangjiang, is an ancient irrigation system in China, originally constructed around 256 years before Christ by the state of Qin as an irrigation and flood control project. It is still in use today. It was inscribed on the World Heritage List in year 2000. In India, the Indus Valley civilization, approximately 2500 before Christ, constructed sophisticated irrigation systems, including reservoirs like this one, wells, and intricate canal networks. The step wells, or baoris, were particularly remarkable, providing a sustainable water source in arid region and showcasing advanced engineering skills. The Romans made significant contribution to irrigation technology, particularly with their extensive aqueduct system. These marvels of engineering transported water from distant sources to cities and agricultural lands. The Romans also employed methods such as terracing and the use of underground clay pipes to distribute water efficiently. Roman innovation laid the groundwork for future development in irrigation infrastructure. You can see on the map on the right top all the remains of Roman aqueducts that have been found. So it's amazing they covered all of Europe and Northern Africa. During the medieval period, the irrigation techniques continued to evolve, particularly in the Middle East and Europe. The Persians developed the Qanat system, a series of underground channels that transported water from aquifers to surface level irrigation networks, as you can see in the two maps. This method was highly effective in arid regions, minimizing water loss through evaporation. In Europe, the Renaissance period saw the refinement of irrigation practices. The introduction of water mills and improved canal systems enhanced agricultural productivity. The Dutch, for instance, became adept at managing water levels in their low-lying regions, using a combination of dikes, pumps, and canals to reclaim and irrigate land. Drip irrigation, pioneered in Israel in the 1960s, represents a significant leap forward. This method delivers water directly to the roots of plants through a network of tubes and emitters, reducing water wastage and increasing crop yields. In 1965, Israeli engineer Simcha Blas noticed that one of the two adjacent trees were growing faster because of a leaking water pipe next to it. He launched Netafim, Hebrew for drops of water, which today supplies drip irrigation systems in 112 countries worldwide. He gave his kibbutz 80% ownership and himself just 20% to better support the emerging nation. While many more irrigation methods could be described, currently the most used ones are classified as traditional and modern ones. Among the traditional ones, we find the check basin method. It is one of the best methods of irrigation for leveled fields. The field is divided into basins according to the water capacity. A small drain connects the basins. The basin size is as per the water inflow. The topmost place in the field is the main source of water. This method does not require any technique. Also, it is rather inexpensive. It prevents soil erosion as the rainwater stays in the basin. A large area can be efficiently irrigated by this method. Furrow irrigation is very prominent in crops planted in rows, meaning to sprout, is formed along the sides of the rows and the water flows between the two dolls. If the furrow is filled, there is no need to provide water again. Strip irrigation. The fields are divided into strips of different sizes. The strips are constructed according to the slope. The structure of the land determines the size of the strip. It is an easy irrigation method and requires less labor. And finally, basin irrigation method. A raised platform is created around the trees and bushes. They are then connected with drains. This method is useful for irrigating trees and bushes and not suitable for crops. However, a lot of water is wasted in this method. This is how water from the lakes, wells, and canals is carried to irrigate the fields. The traditional methods are cheaper and require less labor, but are quite inefficient. Therefore, modern methods of irrigations are implemented for better yields. Drip irrigation, among the modern ones, involves delivering water directly to the plant root zone, drop by drop. This ensures precise and efficient water usage. Drip irrigation not only conserves water, but also prevents soil erosion. Additionally, by delivering water directly to the plants, it can reduce weed formation. Surface irrigation refers to delivering water directly to the field surface. This method involves using irrigation channels, reservoirs, or pressurized pipes to distribute water across the agricultural area. Surface irrigation methods include pressurized irrigation, irrigation channels, and so on. Subsurface irrigation involves delivering water directly below the soil surface. This method targets the root zones beneath the soil surface. Subsurface irrigation reduces evaporation and optimizes water uptake by plants. And then sprinkler irrigation, which involves spraying water at high pressure across the agricultural area. This method is commonly used in large farming areas and can include mobile or stationary sprinkle heads. Sprinkles irrigation ensures uniform water distribution, promoting consistent watering of plants. These irrigation methods can assist farmers in utilizing water resources more efficiently. The 20th century brought a revolution in irrigation techniques, driven by technological advances and a growing understanding of water management. The development of motorized pumps, sprinkler systems, and drip irrigation transformed agriculture, making it more efficient and sustainable. Moreover, the integration of artificial intelligence and the Internet of Things in irrigation, IoT, holds great promise. Smart irrigation systems can analyze weather data, soil conditions, and plant needs in real time, ensuring precise and efficient water application. So-called smart irrigation is now being used by more and more farms. It is estimated that agri-tech data is capable of saving 18% to 30% of the amount of water a farm uses. Orbiting satellites using advanced imagery can detect areas where the crops are under threat and need more fertilization. Optimizing the amount of fertilizer required will reduce the adverse effect that these chemicals have on our environment and will also help farmers to lower costs. However, it is the introduction and use of sensors that have allowed agriculture to take the next step. Without them, smart farming simply would not be possible. You can see some of these sensors here on the graph, on the image. Smart sensors provide the data that enables farmers to monitor and optimize crops, as well as being installed in the ground to monitor and report on soil moisture. Smart sensors can be fitted to weather stations, plus drones and robots. They can also be precisely controlled using mobile apps developed expressly for this purpose. There are different types of sensors: electromechanical sensors used to detect soil nutrition, mechanical soil sensors, optical sensors which use light to measure soil properties by measuring different various frequencies of light. They can be placed on vehicles or drones, which then collect soil reflectance and plant color data for processing and analysis, temperature and humidity sensors, location sensors, and so on. A study in Nature is telling us with this map which areas are most equipped with irrigation. We can see how Europe and US are well equipped, but India and China have a much higher intensity. This other map is showing us the predominant irrigation methods in different parts of the world. We see, for example, Israel and Spain, great use of dripping technology, while sprinkles are predominant in US, Canada, Brazil, part of Europe, South Africa, Russia. Finally, surface irrigation, a bit more traditional way of irrigating, is predominant in most of Southeast Asia, Australia, and Africa. Finally, this map tries to depict the likely more problematic areas for future development, such as India and China, where this study expects, at least in part, a future unsustainable development, likely increasing water stress. Let's now have a look at studies which have tried to compare crops' irrigation water footprint, the water footprint of each different crop. We need to understand that crops need water for the reasons we have explained. The plant extracts it from the soil via its roots, and it loses it via transpiration and evaporation, as you can see on the graph. The water need of a crop is usually expressed in millimeters per day, or per month, or per season. The crop water need mainly depends and varies upon climate, crop type, growth stage, and the growth period, as some crops have much longer growth periods and will need water for a much longer time. The irrigation water need, instead, which is different from the mere water need of a certain crop, is obviously the difference between the crop water need and the part of the rainfall which can be used by the crop, the effective rainfall. So on average, crops have different irrigation water requirements, but this will change in different geographical locations and over time. So it is almost impossible to calculate these values as a definitive global value. Additionally, when comparing, one should consider the nutritional properties and amount consumed per portion of the crop, and so on. These are only some of the results of one or two studies which have tried to compare water footprint of some products, simply comparing liters per kilogram and not per nutritional value, for example. Apparently, cocoa, coffee, nuts, tea, and spices are those using more water, but the study does not specify if it is only irrigation water. A good example of a legislative effort to improve water use is the EU Water Framework Directive, WFD, adopted in 2000. Its key objectives are to achieve good status, ecological and chemical, for all EU surface waters, groundwater, and transitional coastal waters by set deadlines. Sustainable water use based on long-term protection of water resources, river basin management plan as central tool, public participation, and the polluter pays principle. While the WFD, the Water Framework Directive, does not explicitly mention irrigation, it addresses agricultural impacts through Water abstraction management. Member states must set sustainable limits on water use, including irrigation, to prevent overexploitation of groundwater and surface water. Pollution control requires measures to reduce agricultural diffuse pollution, e.g., nutrients, pesticides, via RBMPs, linking the nitrates directive and promoting buffer zones or reduced fertilizers use. Efficiency measures encourages water-saving practices. FD drives a holistic approach to balancing agricultural needs with ecosystems health. Additionally, consumers' awareness is growing, and companies using agricultural products are starting making claims related to appropriate water usage. In this Greek study, we recognize the importance of saving water in all sectors of the economy. The consumers recognize the importance of saving water in all sectors of the economy. These other statistics shows that 80% would prefer to see on the label the water needed for the production of the product. 75% is willing to pay 5% more if the product chosen was produced with lower water use. As a consequence of the increase in awareness and the new legislations introduced, the market has started to propose other certifications, which tackle the issue of making sustainable use of water in agriculture. Some have been developed by Global Gap, by ISO, by EPA in the US. ISO, Friend of the Earth, considers some certification programs equivalent in full or in part. So if a company is already, for example, Spring certified by Global Gap, it can apply for the use of the Friend of the Earth Sustainable Irrigation logo. Or if the system is already WaterSense certified by EPA, it is likely already compliant at 70% with the Friend of the Earth standards for irrigation solutions. As I previously explained, the Friend of the Earth certification focuses on the certification of products from sustainable agriculture. Sets of certification standards have been developed to audit agriculture, farming, and processing companies. The agriculture requirements of Friend of the Earth standard focus on the agriculture management system, with strong similarities in this area with the integrated pest management standards. Additionally, the standard evaluates the potential impact on pre-existing natural habitats. It also requests protection of any endangered species currently occurring in the agricultural site, as well as appropriate energy, water, and waste management. The Friend of the Earth standard itself requests a rational use of water resources, as you can see. Within the most recent Friend of the Earth certification agricultural standards section requirements are set specifying requests and requirement for water management, which entitle the successfully audited company to display the Friend of the Earth Sustainable Irrigation logo on its products and claims. Companies can also apply exclusively to be audited versus the water management requirements, the sustainable irrigation requirements. So the company must use sustainable irrigation certified products. Additionally, it must have carried out a water risk assessment covering factors such as contaminants, evaporation, leaks, soil erosion, treatments, and setting out consequent objectives, procedures, updates, and training. The company must prove, of course, compliance with the law and go further, implementing best practices, including recordings of water consumption and soil humidity, and consequent irrigation cycles. Rainwater and water in general must be recovered to the best possible levels. Fossil water cannot be used, and the approach must be considered, and the watershed must consider the watershed in its entirety. Buffer zones must be respected, 10 meters from water sources and wetlands of protected areas. Soil erosion must be prevented. Irrigation solution systems and their providers can also apply for Friend of the Earth certification as innovative sustainable products and systems. Here I am providing some examples of claimed reduction on average reduction on some environmental factors such as water and energy consumption generated by some innovative irrigation solutions. drip irrigation is normally the one claiming to generate the major reduction in water and energy, but others can also qualify for the Friend of the Earth certification. So I hope you found the webinar interesting and that it provided useful data and food for thought. Feel free to contact me or our team in case you wish to apply for the Sustainable Irrigation certification or simply obtain support and information. Together, we can create a sustainable future. Thank you. And we can now pass to the question and answer as well as the polls. Here we are. So here I have the polls, which I usually show you at this stage. I start the first one. The question is, which of the following irrigation methods you think is the most efficient, sustainable? There are the traditional ones like basin, furrow, strip. If you followed, you might recall. And then you have drip irrigation, the one developed in Israel in the early 60s. There is a sprinkler irrigation, the one you most often see when you go on the highway, at least in Italy and in many other places around the globe. The subsurface irrigation, which actually brings water to the roots and reduces the risk of evaporation, or it's impossible to tell because it's too complex to compare, or because each crop has its different needs, etc., etc. So you can vote on this, and I will show you the results at the end. And I have a second poll. Which of the following crops has highest water footprints? You know, we read a lot about this. You think it's coffee, it's cocoa, it's tea, it's potatoes, or it's impossible to tell. I've explained that it's quite complex to make assessments of this kind because of different factors that have to be taken into consideration. However, you might still feel that on average, some of these are more likely to have a higher water footprint. The third poll is, would you prefer to see on the packaging? We've seen that some consumers in Greece seem to prefer quite loudly to see on the packaging of products a label, not a label, but the liters of water used for its production, instead of a label confirming it was produced by means of sustainable irrigation. So you prefer to see that one label and that's it, or you want to know also how many liters, or you want both information, or you think it's not possible to evaluate, or you're not, or it's not interesting for you. And then whenever you want, we'll be delighted if you could vote the webinar so that we have an idea of whether you found it interesting or not. And of course, you can always write to us, if you have comments and you want to request a webinar or something different. Okay, so this said, while we let you all vote, let me get to the questions. We have a couple of questions already. Well, one question is more technical. It's quite common. If we provide a certificate, yes, if you stay until the end of the webinar, you will receive a certificate from our marketing team. And yes, I think the questions are all regarding the certificate. Well, we are glad. It seems that, and you deserve it, because if you listen to me until now, I think you have been very patient about this. So let's see. If I don't see questions, I think the presentation, I believe, has been quite comprehensive. So and you can always send us questions later on by email. You can write to my name and surname, Paolo Bray, at friendoftheearth.org or friendofthesea.org. And okay, well, while we wait for eventually other questions to come through, if you have while we wait eventually for other questions, I will start showing the results of the 3 polls. And apparently, there's some of you are in favor of there's let's say there's different opinions regarding what are the best and most efficient irrigation methods. So as you can see, that there are votes for each one of the systems, and let's see, something similar happened also for the poll regarding the highest water footprint crop. Rightly, potatoes seems to be on the low side, at least from the studies that I found. And the third poll was asking about what you would like to see on the product, and most of you are asking for both, and differently from the Greeks. With all respect to the Greeks, apparently our audience today is more in favor for just the sustainable irrigation label, or both, but not just the liters of what is used to produce. Okay. So I see some changes going on. I don't see any questions, so I think the presentation has been comprehensive. And if you are interested in our sustainable irrigation certification, please feel free to contact us. Consumers want more and more transparency, want to know the history behind the product and how it's produced. And water consumption is obviously quite an important impact factor. So they want to know about that too. With this, I thank you for participating to this webinar, and I look forward to see you on the next webinar on Friend of the Earth certification and update. Thank you, and have a wonderful rest of the day.
Help our planet with this first step. Follow Friend of the Sea and Friend of the Earth across our social media. Like this video and subscribe to our channel. Your follow and subscription helps us spread the sustainability message to everyone. Let's build a better world together as sustainable friends.